I came up to the Holmdel Horn Antenna today to participate in the 5-watt challenge. It's a great place to do radio. It's very high. I've been here many times before over the past 5 or 6 years. And something amazing is happening here today. You can see in the background these items here. Well, it turns out there's a group of physics students from Harvard University in Cambridge, Massachusetts, who are here to do experiments to measure the cosmic background radiation, much as Penzias and Wilson did from the Holmdel Horn Antenna. And so what is absolutely amazing is that obviously they have access. So I was able to go up into the cab, the control cab, where Penzias and Wilson did their experiments. Building 3 is open. I was able to go in there and see a lot of the control panels. There's huge vacuum tubes, probably from a power supply. So they all took a break for lunch. I'm just kind of keeping an eye on their stuff. But here's the most amazing thing, is they told me that this afternoon Robert Wilson, Dr. Robert Wilson himself, will be coming out to give them a tour. And this is just incredible for me. So I have canceled all my afternoon plans. I'm hanging around, doing everything I can to help these folks out. And hopefully I'll be able to get some video of Dr. Wilson and his tour. So hope you all enjoy this, and just an incredible day here at the Holmdel Horn Antenna. I am here in the control cabin of the Holmdel Horn Antenna, and this is a dream come true. I came here today to do amateur radio, and there's students from Harvard with experiments down below measuring the background cosmic radiation, which of course is exactly what Penzias and Wilson did here all those years ago. And I've been told that Dr. Wilson will be here this afternoon. This is a dream come true. So here's what it looks like. This is the control panel that Penzias and Wilson used to control the horn, to detect the background radiation that confirmed the Big Bang Theory. And this is just amazing, an amazing stroke of luck that I've had to be able to come up here today. Right here in this room is where they made their discovery. And this is looking into the horn, and you can see the metal at the end of the horn. So this is extremely fortuitous to be able to be in this room. And they said that I could watch and listen when Dr. Wilson was here. I had to promise to stay out of their way, which would be fine. But this is absolutely incredible. And here you can see this is the end of the horn. So this is just absolutely amazing. So I'm going to stick around, and I want to hear Dr. Wilson, and maybe, just maybe, fulfill my dream. Yeah, of seeing this horn move. So this is building 3, which is the building that's right next to and down from the horn. And because of my new friends from Harvard, this door is open, so I'm going to take the opportunity to go inside. I have always wanted to come in here, and this is one of the places where Penzias and Wilson did some of their work. Now, some of the things in here are more modern. This looks like phone switches. But over here, I mean, look at these tubes. I mean, these are just incredible. These are huge vacuum tubes. This could be power supplies, it looks like. You know, I'm not even sure, but just incredible things down here. And then over here, and I'm gonna switch, I don't think I can do that while I'm talking, but here we can see control panels, okay, for azimuth, elevation, and some other control panels for the horn. So they could control from up there and from down here, I guess. And this is just incredible. So yeah, inside building 3. at the Holmdel Horn Antenna.
If we direct the beam fully up to zenith in the sky, the contributions from the atmosphere and anything coming from the cosmos. And as we tilt down, as you all know from the second exercise you worked through, we'll be increasing the path length through the atmosphere. So just in direct proportion to the air mass. 6.6 Kelvin. Okay, that's from temperature right now. Well, we'll see. Okay, so let's do a sky dip. Jack, what's the target? 90. Okay. This is 89. 104. Some white stuff up there straight up. Receiver temperature here is around 90 Kelvin or so. Much higher than Bob's receiver temperature. And our calibration points are...
And since satellites might move fairly quickly, low altitude satellites, well, there used to be a 60-foot standard dish down there, which was used to transmit something that was received by JPL. And they saw the drive system for that. It had 10 horsepower electric motors, and they just ordered up another set. So that's why there's such a large motor on this thing. It could really whiz around originally, although it doesn't move so fast now. And when we started using it for radio astronomy, I sort of slowed it down and made it more accurate. Let's see. So I guess you see how it moves. Have you seen it move or? No. Okay. Do you want to ride? In that building, there's the inverse of these motors. There's a couple of motor generators that are 10 horsepower that were used to drive this with some... It's too bad the thing doesn't work anymore. They're hydrogen thyratrons there that glowed blue, and the glowing would change as the drive changed. But now we just have this silly little electronic box. So if I turn on as...
It still works? I was not expecting it to actually start and do.
Or I can move it in elevation.
Wow.
This floor obviously needs some maintenance. Let's see, we can go up here. There's an interesting thing in here which you can't see. Unfortunately, I don't have a key to this lock. I don't know who put it there, probably the new owner. Anyway, there's a big thing in there which is an analog computer. One part of it is an analog of the Earth rotating about its axis, and the other part is an analog of an antenna with an azimuth elevation drive, and the two are linked So you drive the Earth at a sidereal rate, and it reads out the as and L that the antenna is supposed to go to. And the whole thing cost about $25,000 worth of shop time in 1950 or 1963. And surely your phone would do a better job. We used to mount the liquid nitrogen there and had a pipe running up, so we had liquid nitrogen delivered to our cab, and we would buy the helium. There was a hoist on there. We could lift it up. Some of you can look in there. I don't know. Any of you want to stand up and look anyway?
I tried taking a picture of it.
And I guess a little later we're going to put a speaker here and aim it out across the hill, across the way there, and you can hear what happens. It's also possible to shout in here. But for years there has been a Crawford Hill picnic a couple of times a year honoring people who had service anniversaries, whatever. And the picnic would be located over there. They would turn this thing around and put a little speaker. No. And it made enough sound over there to
Awesome.
That's amazing.
high gain audio system.
Oh my god. That's so cool.
Well, you'll get to hear that. As I say, well, the chart recorder was here, I think. Maybe it was over there. Anyway, there were racks of equipment here and a giant thing with the maser here, the cold load sitting right under here. I had to walk around. The original color in here was that greenish color, which was actually the color of almost everything at Crawford Hill, all of the interior walls. There was a mad Irishman working for us for a while named Jerry Rickson. And Arno said, why don't you get the cab repainted without saying what color? And he picked this color.
Dr. Wilson,
Yeah.
I saw a video of you up here with the young woman and who was a musician.
Yes.
Remember that?
Mm-hmm.
Yeah,
Right.
and she wanted to play her music to the stars.
Yes. So we did it. Well, I explained to her that audio wouldn't go beyond the atmosphere. So we had both a speaker here, and I think that was the signal generator that had a modulation input. And so we modulated her music on the signal generator and put an antenna in here and transmitted her music up into the universe to disperse and be lost forever. She actually did some interesting things at Bell Labs. At Murray Hill, there was an anechoic chamber, an acoustic anechoic chamber. It had an acoustic absorber all around it and sort of a mesh in the center you could walk on and put instruments. It was for making accurate acoustic measurements. So she wanted to do some music that was without any environment. So this was a perfect no environment place to make her music. That I thought was an interesting idea. Let's see. I guess the last use of this, someone put maybe that was put here this morning. A tilt meter. Those readouts were Cold War surplus from some radar. let's see, I guess on that thing there used to be a hairdryer hanging. So when we, after transferring liquid helium or something, we need to warm it up, we could use a hairdryer. And that clock kept sidereal time. It was a standard clock, except we had the shop make a 5-gear converter that converted the rotation rate for standard time to sidereal time. It looks like it has not survived well.
When was the last time this facility was used, or the horn was used?
I think the last time it was used, one of Dave Wilkinson's students did a 400 megahertz experiment here. I think he had to take, maybe it was the lowest frequency that would go through this. Mm-hmm. And made a measurement of background plus galaxy.
Cool.
But since then it's just been here. Let's see. There were originally 2 room air conditioners in here, and they modulate by turning the compressor on and off. So it gets cold for a while, and then it gets warm, and then it gets cold, which is not good for instrumental stability. So you can hardly see it, but in the duct from the one behind the door, we ducted its cold air up, and there are some heaters up there. So we turned on the air conditioner full blast, and a circuit I built in that little box would modulate the heater. We didn't care about energy in those days. And that made the temperature much more stable in this place because you could modulate the heater. And this is the control panel. The Selsons in that and the equivalent one in azimuth would drive these things. And we could lock the fine one on and actually turn this to drive the antenna. But generally we would, we had the coordinate converter down there, and but originally when we wanted to observe a source, we would we would look up in our printout, computer printout, where to put azimuth and elevation a little bit ahead of the source, and then wait for the Earth's rotation. But after we got the coordinate converter, then we could actually track sources and purposely move on and off. That was a much better observing method. And there's the phone. And you may or may not recognize that, but that's standard telephone equipment for the wiring, because that's what was available. And, I think someone swept in here. Yeah, this was much messier. There is a row of houseflies over here. And I guess I don't see them on the floor anymore. Anyway, the best evidence for continuous creation was the existence of houseflies in here. We didn't know where they came from. There was nothing to eat in here. But we would get these giant houseflies flying around in here.
The loops on the ceiling are for?
I think that was the Princeton experiment. They were hanging something up there. I'm not sure what it was. In fact, it looks like there's several. Oh, and this was for lifting things, but I don't think they weren't there when we were using it.
I remember it's holding exercise.
I don't remember what that's for. Nothing I ever used. Yeah, that's strange. I may have known at some time, but I don't remember now for sure.
Do you have any favorite memories in here, like with your colleagues or?
Well, mostly was Arno and me, and we largely stuck to what we were doing. It was a little boring at times. At one point, I guess I had set up a table here and had the chart coming off and was reducing the data as it came off. But most of the time we made our chart and then the next day we reduced the data. But it was definitely a hands-on sort of thing, and we would plan ahead generally what we were going to do, but the details got worked out at the time. Yeah, I don't remember any particularly good times. I guess it was always nice when some new thing worked the way it was supposed to. And I don't know that I mentioned to the group of you, but as you walk in the back door of the building, after you get in, I don't know, 30 feet or something, the whole area off to the right was a machine shop at the time. There was another big area that was a carpenter shop, and they had some very good machinists, and it was easy to get any kind of waveguide thing or anything we wanted. They referred to our drawings as cartoons, but anyway. I'd actually had a mechanical drawing course in college. They probably don't teach that anymore. But it was fairly easy to specify what we wanted, and they understood a lot of things, which was really handy. I guess one memorable thing was getting the call from Walter Sullivan on that phone.
Wow.
Yeah, what can that have been for? I can't think of any reason for their having done it, but obviously it was done for some purpose. So there also was a vacuum pump, a big 4-pump, down in a box under there. So we had not only liquid nitrogen up here, we had vacuum up here whenever we needed to pump out a door or something. Maybe we ought to do I wonder how they're doing down there. Experiment.
Sounds great.
Although, let's go see. Do we want to do the tone first? Okay, that's fine.
Let's try the tone first.
Okay.
I'm full max on that. I'm surprised that they haven't put this in a museum or memorialized it or there's not more upkeep.
We had a visual, I guess there was a laser at the other end and a receiver, a little or mirror here with a photo detector.
This little shack right here?
That little shack. That was measuring the optical transmission from the black box to here.
Ah, okay. And what went on up in that, on the tower?
I think it's some sort of measurement for mobile radio, but that was after I was here.
Yeah.
We set up a far infrared in the larger shack, 10 microns, but still, if you couldn't see the other end, it tended to lose all its signal.
Right. I did climb the stairs once. There's loosened gear at the top, so I know it's fairly recent. And then these, the point-to-point microwave,
that has a view to Murray Hill.
That's what we all thought. That confirms it.
Yeah, Mike Gans did an experiment.
And
I think he also had an optical link. There's a type of fading when there's a refraction and it moves the radio beam up. And he was trying to see if the optical beam would go through at the same time.
Interesting. Now, I have to ask, I spent years working for CBS News and satellite news gathering. So I see that dish. What was the dish? You know the dish right around the corner?
Oh, no, that is well, it's a telescope we built to do millimeter wave astronomy. And it also measured the signal from a satellite at millimeter wavelengths. At 16 and 30 gigahertz. The Comstar satellite had a beacon. Is this an Allen wrench you brought, or is it?
You unplug it back, turn off the power later. I don't know. Oh, probably not. That's fine, but not turn off.
This is an Allen wrench you brought, or is it one of those?
No, this is one of yours.
Okay.
That's one of yours. But
I may have mentioned that's an Arno invention, to have two of each. So when you lose one, you're still in business.
that's cool.
The stockroom was free, basically.
Yeah. So I suppose what we could do, since we've got it hooked up, is we could assume the calibration from down there for an initial measurement.
Yeah.
Okay, excellent. Please give us a fresh tab for this.
Let's see. You want to run it to try to put it at specific angles, or just?
Data and measurements 2, and then data and measurement 1, the measurements 2 through 5 are handy. So we'll probably want to consolidate at some point.
Okay. This is a different spreadsheet, you said?
Looks like it.
Huh. We have more than one on there? Okay. Okay, so we can turn it on.
Which I put for radiometry.
Elevation angle should be slightly negative now.
And it looks like it is by it's 3.8 degrees right now. I don't know. I hope Bob's got a microphone. That's the important.
He does.
Okay, very good. Okay, so you've got the 11 gigahertz Potter horn.
I got 11 gigahertz, probably
20 foot Bell Labs original horn. Excellent.
So how do you want to? Do you want to run it continuously and take off data at points, or?
No.
We'll probably want to redo the pressure because the height difference is going to be about a millibar.
Okay, that's good.
I don't know if that's going to make much of a difference in the actual calculation.
Very slight, but you're absolutely right. We can measure the pressure now that we're up here. I guess they're having...
It should be accurate enough. The phone sensors are usually good to about resolution of about 30 centimeters.
Oh, we can measure the difference between our floor and our ceiling.
Yeah, no.
So you're getting 88 point. I'm getting 88.6.
I'm getting 88.8.
88.7. Okay.
Sure. 988.7 millibars. Awesome. How is the radiometer stability?
It looks reasonable.
Oh.
Okay.
Okay.
It's
And we're picking up something close to 300 Kelvin right now?
yeah. Well, calibration is from the other radiometer, but the values are similar to what we were seeing before. It's 362 millivolt.
Okay. Okay. So hopefully that means that we're well coupled to the ground.
Yeah.
Is that
The Dutch would run their antenna down so it was looking into a local woods that was full of pine trees. And when
okay?
I guess they had needles all year long.
That's awesome. So the reflection off all of the, I guess that's as good a black body as you could hope for with all
Right.
of the features in that. Okay, so so I think we're going to want to step to just
Right.
a few discrete elevations.
Mm-hmm.
We were doing it really going from 90 to like 70 to 60, 50, 40, and then you go back up from there, and that's enough.
Okay.
But the zenith temperature is going to be the most important thing
Shall
for us
I
to check
run it
right
up
now.
to 90?
If you can run it to zenith, that would
Roughly?
be awesome. Fitted?
No, don't say override.
So we've got the elevation measurement there with our very sophisticated sensor. Bob's going to take it up close to zenith. This is the same thing that we were on.
Okay.
So it will be very interesting to see how it compares with this. We haven't recalibrated yet. That will be the dramatic part when we have liquid nitrogen gushing on the floor of this historic facility. There's our ambient temperature load. It really is not changing, so I'm not...
Changing, it looks like. Well,
How are the clouds above us right now? What does the sky look like?
There were droplets for a few minutes.
Zenith through 20 foot. Yeah. And
It's
some...
definitely changing now, so I think we're seeing clouds now.
Okay.
One up a little bit.
Okay.
Fine.
I'm going to get a visual on the clouds up there. Oh boy. Half a Kelvin or so? Maybe that's not horrible. Okay. I think we can keep our fingers crossed on getting blue sky in a few minutes, but how about we do a proper calibration?
Do
Or-
an
or-
upward measurement for this, or just wait?
Well, we could do a sky dip and then a calibration and then another sky dip. If Bob, if you're willing to do
Yeah.
a few sky dips,
Yeah.
we could. Yeah, okay. Let's try that since it does look.
You can grab the route here.
Blinding a little bit. You know, I actually think that those vice grips are probably a better idea than these bolts. We'll put the studs in.
Studs and best grips.
Studs and vice grips.
All right.
Yeah, it's binding.
Do you want me to try to lift it in any specific direction?
Great. Let's go down on, and I'm going to tilt it towards me, because I think we want it to be in this orientation. All right. Okay. Should we do another one?
Sure.